the end-to-end service approach. If we take a look there and say, okay, what is here happening? You have there various approaches, various levels combined together. And those combinations allow basically to have an end-to-end ecosystem, which is provided partly by the operator, by partners, by direct application providers integrated to the services and the operator, and for sure, the full ecosystem with integration engines, software coding engines, and others. So if we take a look here and say, okay, if this is the whole ecosystem, how to build it, how to, let's say, tackle it. And we have there mainly 3 pillars defined, which help to have this open ecosystem implementation happen. Number 1 is to have integrated and joint innovation focus, integrating 5G or telco with AI, with IoT, going to the cloud, going and integrating big data to have more resources for operations, for automation, for orchestration, and for sure also decentralization, going to the edge cloud, using basically open third-party cloud infrastructures, public clouds, or distributing your cloud infrastructure yourself. The second pillar is the ecosystem. And the ecosystem is, as you can see, the let's say, broadened scope of telco. It's the terminals, it's the application, it's content. It's really to have there an end-to-end integration of the service. And those 2 aspects alone allow you already to broaden, to wider your application market. So having for the 2B market tailored products for certain 2B applications, having their middle platform offer, having their basically a specific focus for specific industries in the offer, or for the 2C market, promoting basically edge computing services, 5G innovative applications, gaming, AR, VR, and promoting good experience for customer sets. So this is basically the main, let's say, recipe to go further. This is basically then finally allowing us to show an end-to-end open cloud ecosystem with an edge DC, a central DC, some public cloud to third-party integrated, with an openness architecture, using a converged hardware, using a cloud infrastructure, for example, ours like text cloud infrastructure, which is based on OpenStack, having a common core, having a fully automation service, and an end-to-end integration. This allows basically to deploy any service, any size, anywhere, open, modular, structured, layer 2, layer 3 decoupled, anytime, with a very, very high efficiency, low time to market, fast throughput, fast processing power, and tailored. So it's really the open approach going further and say, okay, you have the full set of all. In addition, not all your sites, not all your resource pools will be structured the same. You will have small scale edge resource pools. You will have medium scaled aggregation resource pools, big scaled core resource pools, or public resource pools. So it is important to react on, let's say, the resource availability on the site. If I have already on the very far edge, very small resources available, loading there a full hypervisor platform with a full ecosystem, with a full automation might not be the beneficial way, because then you have no resources to compute anymore. So the idea is then really, if we have this broadened world from the far edge to the core, to really structure the infrastructure and find the right level of, let's say, deployment size for each of those infrastructures. To going for an ultra edge on a low scale, small scale, lightweight deployment, to going for the edge for a lightweight deployment with some HIC hardware, to have there on the standardized side, dual core containers, virtual machines, dedicated COTS hardware, and on the main DC, really the full orchestration set, the full service set deployed to have the right set on the right size. This allows basically to deploy really open, all-in-one ecosystem, allowing containers, virtual machines, computing with a KVM hypervisor layer, with a software-defined storage, with a software-defined networking running on COTS hardware, with unified management of service, of operations, of resources, or cloud management, to run and offer a service. And this service is basically one for all applications you want to use. You have there for Mac computing, campus computing, IMS deployments, voice deployments, data deployments, applications, third-party integrations, all sets, all with a common orchestration on top, saving energy, resources, services, integration time, making a simpler network, a better experience, less investment. And now, as one add-on, if we take a look what brings you 5G SA and NSA in addition. You can get here still voice data services, gigabits per month, megabits per second. So they're classic service infrastructure, no need to change for, but allowing this 5G SA to go for bandwidth guarantees, slicing per location, per service, per infrastructure, latency services, reliability services, number of devices for IoT or for, let's say, smart metering or smart city services, dynamic SLA services per location, per service, per type, and also then basically the full encryption and authentication benefits 5G brings, because a new security, let's say, landscape is embedded in 5G standalone. At the end, this helps you to go on a very, very structured approach for digital services. Having a distributed set supporting a wide variety of hardware for converged COTS hardware, dedicated traffic offload services, acceleration cards, built-in security cards, SDN controlled network. And on top of that, you have shareable services, technical shareable services, high-level shareable services, which you can modularly combine together to build a template-based application structure for your tailored services. If you want a specific medical rule set or transportation, manufacturing, financing to be rule set, all of them in a very easy way, automated and automatically orchestrated on a DevOps space, with ensuring lowest latency, highest bandwidth, and highest security. To build such an ecosystem, it is a, let's name it, simplified structure, even it looks not very simple. What is needed to do so? So number one is you need a transport infrastructure with an open gating system to the compute infrastructure. Again, on top of that, a platform to allow basically to onboard services and applications. On those platforms, you have then basically your application infrastructure ready. You have big data to extract out of those layers all the data information to make a fruitful, efficient orchestration and automation. And then this brings us to the last point, having an orchestration management and AI system, enabling the full service infrastructure for own or third-party products. I'm famous for overloading slides, sorry for, here it is. It allows basically here to say, we have here really from transport layer, the gateways, the spine, the leaf, all of them on the infrastructure, running on top of them, COTS hardware, edge platform hardware, node engine hardware. Going on top of this, having their platform supporting open pallet for containers, open stack for virtual machine, a storage architecture supporting Ceph, with a technical network architectures on OVS, DVS, SRIOV, and acceleration services, utilized by applications for edge platform, core platform, common service platforms, which are modular, combinable for your service you would like to do, own or third party, with a big data system for tracing, collecting, structuring, analyzing, learning, storing the data, and forwarding to the orchestration layer, which gives the impact on, or gives the possibility to have there an orchestration on the resource layers, an orchestration on the virtual network management functions, and an orchestration on the service and slice. So really an end-to-end orchestration for your service set. This full set is allowed to be, let's say, launched by an integration platform. So 5G is the first, let's say, telco generation, which has an NEF function, and standardized API gateway or capability exposure platform, allows basically to interact with 2C or 2B service applications to directly steer and control and modify SLAs of certain groups of subscribers related to this application, allowing basically direct interworking on the network capabilities for our standard throughput for IoT services, for basically the full SLA scope, with dedicated impact on the efficient handling on the perfect subscriber experience. So you have there really the possibility to have a vertical integration for 2B and for 2C. Allowing all of this together and taking a look on a standard network with a mast site, or several of them to be honest, edge sites, aggregation DCs, and core DCs, you have there the possibility to deploy your radio units from the mast to the edge to the aggregation DC, and if you want, to the core DC too. You have your control and user plane spread all over your network as you need it to fulfill your SLAs for your 5G SA set. And you have for sure certain edge computing environment, which allows you to be placed then on the edge set, building an end-to-end virtualization infrastructure with a full virtualized scope, and the possibility to interconnect to certain peers, peering points, interconnection points, B2C, B2B points, or campus networks to offload or interconnect traffic. This is the complete scope to go for, and for the complete infrastructure, it allows basically this kind of wide deployment mode. To be able to do so, you have to have the right equipment at the right place. Sounds maybe a little bit obvious, but the thing is, if you go to the very edge point of your network, your environment condition is not as comfortable as you would be in a data center. So if you would try to use a standard COTS hardware or a standard indoor SFP on the site, which ranges from -20 to +50 degrees, the time of surveillance might be not so high. So the thing is, number one is, to the edge, you must find a way to tailor with harsh environment condition, and you must find a way to put in solutions which are smaller in size and still powerful. This doesn't mean COTS is not good. Don't get me wrong, COTS is perfect for any data center infrastructure. But if you go for harsh environment, still it's Intel, still it's SRIOV, still it's the standard x86. Don't get me wrong, but it is to go for better temperature hosting, for harsh environment situations, for better filter infrastructures, and for smaller condensed sets. Like our ZTE ZXTP, this is a telecom edge platform, modular Intel based. You can put it there, deploy it on certain exposed places where you need high performance on processing high throughput services, like on a regional DC or like on an edge DC. You could have there basically a Mac computing engine with the VCU Mac computing board, which allows you basically having there on a CU side directly enhanced Intel performance, which allows you for virtualization, containerization, cloudification, running applications there, interacting there, and having a Mac platform running with an interconnection set there for service applications. And last but not least, the VDU VGC board. This VGC board is named Node Engine. It means you have there a BBU on site or a DU on site, and you can put in a 2-slot big card with an Intel processor on it to run it for virtualization layers. So helping you basically on the sets of infrastructure on the sites you already needed to have there an end-to-end computing pool ready, able to be utilized by a dual engine for OpenStack and for Kubernetes, having basically containers, virtual machine on this open platform, able to be utilized by own and third-party applications. This all is automated and running well with a full automated enhanced network management service. It is really doing, based on DevOps, the full, let's say, automation scope on service guarantee, on management for design, network construction design, service construction design, on deployment. So if you have designed a slice or service, you deploy it with a zero weighting. So just click it, it's automatically on a process gap deployed, and a zero touch for assurance, automatically reacting on failures, failovers, and other strategies. For the right services, for the right slices, reducing your O&M costs, the time to market, and basically also the error and trial costs. So it's basically the full orchestration infrastructure on DevOps for your full service infrastructure, from radio over transmission to core, for the full scope of services, including slicing of 5GSA. Now, you will ask, what can I do with it? And to be honest, you still can sell connectivity. Don't get me wrong, there's nothing wrong with that. Basically having an interconnection from A to B and someone uses it. Good approach. Next step is to be a platform provider, which is a subset of a service enabler. So you have a Mac platform, you have an edge platform, you have a core or an aggregation platform, and you let the platform being used for storage, for computing, for whatever, to let it run on third-party applications or your own. Or you go a step further and say you are a service integrator, allowing already integrated services to be used by others, having a one-stop system integration and an end-to-end solution provider option for your services you want to go for your end customers. And last but not least, which is the last and the most exciting step, is to be really a service provider, having really an ecosystem fully deep integrated with consulting plan, with planning integration, operations integration, automatic DevOps services. So having really the full set available on the deployment scope. So it allows you basically with this platform to be all of that as you like. Now, to enable that, you have various layers. You need the connectivity. Basically, you need a service enabler layer, edge computing, slicing, some enabling engines. We as ZTE have roughly 300 plus partners 15 verticals, which work on us together to build this ecosystem, to be able to give you an option to select and have preset defined sets. And with about 60 plus pilot projects and 86 application scenarios already, we have a broad variety of use cases, service cases we already have done for 2B and 2C cases in the market. Like big video cases, EMBB cases, live TV cases, three-dimensional security cases, Internet of Vehicle cases, smart port, smart harbor cases. We have our own 5G factory where 5G components are produced with 5G coverage and 5G ecosystem for all the service constructions. So having a really, for all the scopes of all the services, including massive broadband, edge computing, URLLC, slicing, all service applications possible. To be honest, that's not only fantasy. So we are proud having a customer going with us that way. Not only one, to be honest, but I want to raise one. And we can say, okay, we had basically with March 19, acquisition started. First public call 2 weeks later with set. Having there basically the first tariff launch just 3 months later. Having a continuous expansion of the network all over the time with at the end, the first 5G campus directly integrated by end of 2019. Now, the thing which is where I'm very proud of and which is really great to say is by June 2021, 5G was finally unleashed. So it was the first pilot 5G live network supporting 5G standalone with a full network ecosystem supporting the full 5G SA experience for highest throughput, unified user experience, edge computing, and all together. And it fulfills basically the scope. It fulfills a complete modernization, a complete cloudification, a complete end-to-end 5G deployment, and an increased O&M efficiency. It accelerates the future to build a 10 years future-proof network with optimized radio sites for the perfect fit, with reduced infrastructure requirements by using latest radio products, combining carriers, multiple carriers in one RU, by supporting the latest AAU generations with lowest power consumption, best sustainability, and having there with this an ideal site solution with ideal antenna sets independent if you go for rural coverage, dense urban coverage, indoor or outdoor, hotspot coverage, suburban coverage, everything else well done. This picture you know already, but it shows the real deployment, what is there. With third-party applications, 5G core, edge computing, charging services, NCE, signaling cases, voice cases, everything. At the end, we can say proudly on the 2C market, 2K, 4K UHD has been applied. So TV services, new VR services on stage, QCell and MEC for indoor buildings, Industry 4.0 integrations, biometer for natural environment monitoring and ecological monitoring has been applied. And in addition, for the 2C market, innovative traffic models have been launched. Independent and content-based service traffics and service offers like gaming, music, and others have been raised. And for the 2B market, a dedicated department was established, massive scale of IoT services were done, 4G and 5G MBB services were offered, including campus. So it's really a big step forward and a good proposal for future. I hope it was interesting for you. It was a pleasure having you on the call, and thanks a lot.